Welcome to Polar Coordinates, Chapter 9. So for the polar coordinate system, to form a polar coordinate system in a plane, we fix a point O at called the pole at the origin, and construct O, an initial ray called the polar axis. Polar coordinates r comma theta is where your r is your radius from the pole and theta is a directed angle counterclockwise from the polar axis. Okay, so to do 2 comma pi, you're going to have to go back and know your unit circle again. And again, I've done a basic one here where this is 0, this is pi. These are basically split into 30 degrees. And I will give you graph paper in class that you can use to do some of these on your homework, or you can find them on the internet and print your own out. There's many different ones. If you want to find one on the internet that has all the angles written on it, that's fine. But I'm just going with the basic 30-degree ones. We can always put a 45-degree angle in the middle. So 2 comma pi is over here. So let me get it with a thick marker. Let's do this one. Okay. So all I'm going to do is I'm going to start out and go, every one of these is a radius of 1, radius of 1, radius of 2. So if I want to go out 2, I'm going to go out 2 in this direction. Oops. I can't hit very well. 2, and it's a directed ray towards it. Okay, maybe that pen was too thick. Let's try a thinner pen. Okay, so I'm going to go out 2, make my point, and there's a directed ray towards it. So 2. 3, 5 pi over 6. 5 pi over 6 is right here. Let me change this to an arrow so it's easier later. So this is 5 pi over 6, so I'm going to go out 3. 1, 2, 3. And I'm going to draw a directed angle through it at 3. Okay, so now when you have negative 2, what that means is you're going to go in the direction of pi over 4 like you normally would, which is right here in the middle. So let me draw a 45-degree angle right here in the middle. So this is 45-degree angle. However, when you have a negative, instead of going in the direction of pi over 4, you're going to go in the opposite direction too. So I'm going to go out, instead of going 1, 2, this number right here would be 2 comma pi over 4. So when I want negative, I want to go in the opposite direction, kind of like vectors. I'm going 1, 2. So it should be right here. And there's my directed angle through it. Okay, on 4, this is negative pi over 6. You're not going to go in the opposite direction of pi over 6. You're just going to go down negative pi over 6. So negative pi over 6 is down here. So I'm going to go out 2 and do my directed angle towards it. Okay, so sometimes I might give them to you in radians or decimals. If you look at 1.57, that is the same thing as pi over 2 because it's 3.14 divided by 2. So I'm going to go to pi over 2 and I'm going to go up 6. So I'm going to go up 1, 2, 3, 4, 5, 6 and put a dot. 1, 2, 3, 4, 5, 6. And there is my 6 comma 1.57. 6.28, negative 3 comma 6.28 would be the same thing as negative 3 comma 2 pi. So again, since I have a negative r value, I'm going to find my 2 pi, which is right here. But instead of going 1, 2, 3 comma 2 pi, I'm going to go in the opposite direction. 1, 2, 3. So I'm going to go 3 over here, directed angle through it. Okay, I want to find 3 different representations of the point 50. So 50 would be 1, 2, 3, 4, 5 right here. Okay, so 50, this I'm giving to you basically as like 0 degrees, rectangular, whatever you want. We're going to change them to rectangular coordinates later, but this basically could be written as 5 comma 0 pi. I can write it as negative 5 comma pi. So in other words, remember, if I had negative 5 comma pi, normally for pi I would go in this direction, but I'm going in the opposite direction. So negative 5 comma pi just means instead of going in the direction of pi, you're going in the opposite direction. 5 comma 0 here, I could also do this angle over here. Instead of calling it pi, I can call this negative pi, which would also be negative 5 comma negative pi. I could also, you could basically call it 5 comma 2 pi as well if you wanted to. So that's a few more than 3 representations, but I gave you 3. Okay, so 4 comma 135. Well, 135 is my 40-degree angle in here. So 4, 1, 2, oops. And I forgot to put that on here. Okay. 1, 2, 3, 4. There's 4. So this one, okay, I could also call, so 135 is also the same thing as negative 255. So I could call this 4 comma negative 255. If I think about the opposite direction that this is, if I kept going the other way, this is 315 degrees. So if I want to use the number, the 315 degrees, to get to go this way, we're going to put negative 4 comma 315 degrees. Negative just means you're going in the opposite direction. Instead of calling this 315 degrees right here, I could also call it negative 45. So I could call this negative 4 comma negative 45 degrees. And that's some other ways to represent those points. Okay, graphing polar equations. A polar graph is a set of all points with coordinates r comma theta that satisfies the given polar equation. So the only polar equations we're going to do in this first section are just basics. If I have r equals 2, hold on, I'm going to make my pen thicker. Okay, basically I'm going to go out to a radius of 2. So everywhere that I have a radius of 2, that's my r equals 2. It's real hard. Okay, next one, 5 pi over 6. Okay, so my 5 pi over 6 is right here. Okay, so if I want my theta to be 5 pi over 6, basically it's this whole entire thing. Because remember, I can write points on here. Let me make the thinner pen, like we did on the last screen, because I could have the points at 1, 5 pi over 6. I could have the point at negative 1, 5 pi over 6. I could have it at 2, 5 pi over 6. I could have it at negative 2, 5 pi over 6. So that's why with the pi over 6, that it is all of this along here. Even though this down here is 11 pi over 6, remember when we write it with a negative, it's negative 2 comma 5 pi over 6. So whether this is positive or negative, that whole entire thing gives me an angle of 5 pi over 6. Okay, I want to find the distance between the points at 2, 30 degrees. So at 2, 30 degrees, so right here, and 5, 120. 1, 2, 3, 4, 5. Okay, so if this is 30 degrees, and this is 120 degrees, that's going to make this angle in here 90 degrees. Now, it's not always going to be 90 degrees, and we're going to talk about that on the next screen. So I went 2 this way, 5 this way, and I want to find the distance, hold on, let me change colors, between these 2 points. So I want to find this is 5, this is 2, I want to find this, and this angle in here is 90. That's basically just a blown up version. So this one you should be able to do with some basic knowledge. Pythagorean theorem, 5 squared plus 2 squared equals d squared. 25 plus 4 equals d squared. 29 equals d squared. So my d, when I square root 29, is going to give me about 5.385. Okay. However, keep in mind, if I give you 2 points, is this always going to be 90 degrees? No. So, if this is any other number other than 90 degrees, like 121, 125, 130, then that means this is side, angle, side. So what formula are you going to have to use when you have side, angle, side to find D? So we're going to talk about that on the next screen. Okay, so what happens if we don't have a 90-degree angle? What if it was 121? So if it's 121 and you have basically a side, an angle, and a side, then that should look familiar to you. And I'll come back to that in a second. So if your first point is r comma theta, r1 comma theta 1, your second point is r2 theta 2. The 2 points are in a polar plane when the distance p1, p2 is given by the equation. The distance between the polar points is this equation here, which yes, you need to memorize, but really, if you think about it, you already know how to do this. Does it look familiar? When you have side, angle, side, that's just law of cosines. Okay, so if I want to find the distance between these 2 points, okay, I'm just going to plug it in my equation. I'm going to make this r1 theta 1, r2 theta 2. So, oops, let me make my pen thinner. So this is r1 theta 1. Oops, not a q. Hold on. It's not going to let me change it. Theta 1, r2 theta 2. So I'm just going to plug it in. My distance is going to be equal to my r1 squared plus my r2 squared minus 2 times my r1 times my r2 times cosine of the angle in between. And you need to do the bigger minus the smaller. Okay, and if you stick that all in the calculator, you're going to get that this is about 5.29 degrees. Remember, that just looks like the law of cosines, which says, oops, you did this earlier, a couple of chapters ago, which was your c squared equals a squared plus b squared minus 2ab cosine c. That's exactly what this is.